All right, we're now on to section 2, which covers subatomic particles. So as you recall, in section 1, we talked about Dalton's atomic theory, and one of the postulates that Dalton had in his atomic theory was that atoms are indivisible. In other words, atoms are like these small marbles, and you can't cut them in half. It's as small as you can go. Well, that actually has been disproven, and it was disproven at the very beginning of the 20th century. And we're going to talk about all of the things that we discovered in this section here. So on the screen right here is actually a nice Cliff's Notes summary table of what we would call subatomic particles and how they were discovered. So what I'm going to do is I'm going to briefly cover each section of the table. But what I want you to do is in your notes, for example 1, I want you to be recording these details that we cover, and I actually recommend watching these very short YouTube videos on each of the experiments about how they were discovered. Just so you know, the details that are represented in the videos aren't necessarily going to be assessed, but you never know what extra credit might pop up, so it probably would be in your best interest to watch them. You can click these links. There are clickable links in the notes, as well as if you look at the teacher instructions, they should be active there as well. Nevertheless, let's go ahead and get started. So, reminder that Dalton just viewed the atom as just this simple marble, right? Not exactly a marble, but just like it. Atoms were just these little spheres that everything was made up of. It could not be cut in half, or there was nothing that composed the atom other than just simply that. But we started to do some experimentation on the atom and quickly realized that that wasn't entirely true. And so there were some discoveries, and I have the discoveries more or less listed in chronological order. So let's first talk about what the word subatomic means. When you see the word sub, that means underneath, right? When you think of a subway, it's underneath the ground. So sub means underneath, and then atomic means atom. So we're talking about particles that are underneath the atom. And the term underneath is a little bit of a misnomer because we think that the atom is like this shell, and then if you open it up like a clam, there's these things inside. But the atom isn't like that. The atom is actually what composes the atom itself are these subatomic particles. And so we'll talk about that. But the very first subatomic particle that was discovered was the electron, and more specifically with that, the charge to mass ratio. And we'll talk about that a little bit in just a moment. But this was discovered roughly around 1897, so right before the 20th century, by a scientist named J.J. Thomson. And J.J. Thomson did this using a cathode ray tube, which was then known as the cathode ray experiment. So what is a cathode ray tube anyway? Well, we don't really have them anymore per se, but if you remember box TVs essentially were cathode ray tubes. Essentially, I'm going to try to draw a TV. It's going to be terrible, okay? But at the back, so here would be your screen. Apparently this TV is broken. Okay, so here's your screen. But at the back of the TV was this particle generator that would fire particles at the screen, and then we would see it on our side displayed on the screen. So essentially this mechanism in the back, this is a cathode ray tube. And here's what he did. He started firing alpha particles, okay? That's the Greek symbol alpha, these tiny little particles. And he was firing them at a screen. And what he did is, and there's actually a better picture up here, what he did was he had electrodes on both sides. And what he noticed is that when he fired a stream of particles, that some of the particles ended up getting deflected. They wouldn't always go in a straight line. They'd end up getting deflected either up or down. And he was wondering, why would such particles be deflected? If everything was made up of atoms, right, and there was nothing else, why was there this somehow attraction or this phenomenon where the particles seem to be attracted in one way or the other? And the video demonstrates it a lot more clearly, but essentially he deduced that there's something in the atom that's charged. There is some sort of charge in the atom, and that is actually what's causing the atom to deviate from that straight line, either up or down. And so through some different discoveries, from some calculations, J.J. Thomson was able to discover that there was the existence of this tiny particle, a subatomic particle, which he called an electron. Now, what does that mean as far as the atom goes? Well, apparently the atom is no longer just this sphere. The atom is now actually, and I'm going to draw it a little bit bigger so I can draw some things inside. He actually believed the atom had these negative particles called electrons, and those negative particles were just sitting in the atom just like this. Now, we knew the atom was neutral, so if these negative particles were to exist, Thomson believed that they were sitting in this positive paste. Okay, so the positive was nothing more than just material. It wasn't necessarily a particle in and of itself. So this model of the atom was developed by J.J. Thomson, and it had a name. He called it the plum pudding model. I don't know, maybe he was talking about it over dinner and he was just super hungry. You know, food can have that effect on people. But nevertheless, plum pudding model is what he called this view of the atom. And that's where it would make room for these negative particles that he discovered. So J.J. Thomson discovered the first subatomic particle, the electron, and it was done via the cathode ray experiment. Now, Robert Millikan was not too long after Thomson's discovery actually discovered a little bit more. He discovered the charge and the mass of the electron. So he didn't discover a new particle per se, but he did discover more information about the charge of the electron and the mass. These actually are on the back of your periodic table that's given to you in the course materials. But when you think about the charge of an electron, a lot of times students think, well, isn't it -1? No, that's the relative charge. The actual charge of an electron is 1.6 times 10 to the negative 19th coulombs. And coulombs is a unit of charge. Now, since electrons are negative, that's the sign. So Robert Millikan actually discovered the charge of the electron. Similarly, the mass of the electron is also found on the back of your periodic table. You don't ever have to memorize it. But that's given as 9.11 times 10 to the negative 31st. And then remember, our SI unit for mass is kilograms. So this was all discovered by Robert Millikan roughly after the time Thomson discovered the electron itself. And how he did it is via the oil drop experiment. Once again, watching the video on the oil drop experiment will actually help explain some of the details. But the idea is he dropped particles through a pinhole, and the pinhole allowed particles to drop in between these two charged plates. And these charged plates allowed some of the particles, as they were dropping, to not only suspend, but to actually flow upward towards the positive plate on the top. And so, once again, through many experiments and data collection as well as calculations, Robert Millikan was able to use that data to determine the mass and charge of the electron. So by 1909, we not only had the existence of the electron, but also a lot of information about it. Now, from that point, Ernest Rutherford came on the scene somewhere around 1911 to 1919 and started to challenge the plum pudding model of the atom. Maybe Rutherford didn't like plum pudding. He just wasn't a fan, okay? So he actually wanted to test that theory. He wanted to see, is the atom actually looking like this plum pudding model that Thomson had put together? And so what he did was he did an experiment called the gold foil experiment. And essentially what he did is very similar up in Thomson's experiment. He fired particles, and he fired them through this little opening. This right here is a screen. And so he fired the particles through that opening in the screen at this very, very, very thin piece of gold foil. When I say thin, I mean thin, like tissue paper thin. And what Rutherford expected to see is that if the plum pudding model was true, what he actually expected to see was the beam of particles should actually pass straight through. But he didn't always see that. Most of the time he saw it, but sometimes he would fire a particle through and they would end up being ricocheted either back or off at an angle. And so Rutherford was trying to figure out, why is this? And after doing some reasoning and some calculations, Rutherford actually discovered that there was this very dense core in the middle of the atom. And this dense core would be known as the nucleus. So there was this dense core at the beginning of at the center of the atom, and then around the atom, were these tiny particles that Thomson had discovered, electrons. So the electrons were not like this plum pudding model, but the electrons, drawn larger for size, because they're not actually that large, were actually zooming around the nucleus. In all reality, electrons are very, very, very tiny. So why would this explain what Rutherford was seeing? Well, he would notice that most of the time, the beam of particles he was shooting through would pass straight through the atom. Most of the atom was empty space, but every now and then, a beam of particles would hit the nucleus and cause it to ricochet, or hit it straight on and shoot backwards. And so that was the essence of the gold foil experiment. And so through that experiment, Rutherford discovered the existence of the nucleus. But what is the nucleus, actually? The nucleus is where all of the positive charge in the atom actually dwells. Because remember, the atom is still neutral. So if there's negative electrons, there has to be positive somewhere. And Rutherford said the positive is actually in the nucleus. Well, what does that mean? The particles that make up the nucleus are the protons. So the proton was the second subatomic particle discovered, and it was discovered by Rutherford via the gold foil experiment. So now we have two particles. We have the electron, which is the negative particle, and we have the proton, which is the positive particle. Additionally, the proton mass was also discovered, and the mass of the proton, which is on the back of your periodic table, is very large. It's 1.67 times 10 to the negative 27th kilograms. Now you may be saying, well, that's kind of tiny. You're right, but relative to the mass of the electron, which is to the power of 10 to the negative 31st, that means that the proton is 10,000 times heavier than the mass of the electron. All that to say, the mass of the electron is essentially nothing compared to the mass of the proton. So that being said, the mass of the atom would not come from the electrons. The mass of the atom actually comes from the protons. The protons, which are in the nucleus right here, are essentially giving the mass of the atom. But the nucleus is actually very small. A visual for you is, think of a football stadium, right? Big football stadium. And if I were to place a marble on the 50-yard line of the football stadium, that marble represents the size of the nucleus. And the whole football stadium is the size of the atom, with the electrons, as tiny as they are, zooming around. But here's the kicker. The mass of that entire stadium, the mass of the whole stadium, would be all found in that tiny marble. So that while the nucleus is extremely tiny, it's heavy. It's where all the mass is found. And the electrons, while extremely tiny and virtually weightless, the electrons are spinning around the nucleus, providing the size of the atom. So now we get on to the third and final subatomic particle, the neutron. The neutron was discovered by James Chadwick in around 1932 via the beryllium bombardment experiment, very similar to the gold foil experiment. And this was discovered because we found that elements such as helium that only have 2 protons somehow had a mass of 4. If the helium atom only has 2 protons, how then was it having a mass of 4? There must be another particle in there. And that other particle is the neutron. And the neutron is roughly the same mass as the proton. They're roughly 1.67 times 10 to the negative 27th. So that is the third subatomic particle, the neutron. Now what's the charge of the neutron? Well, as you may have guessed it from the title of it, the neutron is neutral. It has 0 charge. It only corresponds to adding to the mass of the atom. So to review, these are the 3 subatomic particles. Here are the relative charges. Remember we said that the charge of the electron was negative 1.6 times 10 to the negative 19th coulombs. Well, the charge of the proton is positive 1.6 times 10 to the negative 19th. Same value, just different sign. And so what we say is, okay, for every proton being positive 1, the electron's negative 1 to cancel it out. The protons and the neutrons are found in the nucleus, whereas the electrons are outside of the nucleus. And finally, what do they contribute to the atom? The protons and neutrons contribute to the mass. Notice their masses are roughly the same. Whereas the electrons, not very heavy, but they zoom around the nucleus, contributing to the volume or size of the atom. How do you count how many protons, neutrons, and electrons there are? That's in the next video.